friends and welcome to the channel. So today I am going to solve the problems on a beam element. So on the screen you can see the question. So here consider the discontinuously loaded beam as shown in the figure. The differential equation is valid with the following discontinuous data. So EI is equal to 2 into 10 power of 7 where 0 less than or equal to x less than or equal to 10 meter. Again 10 power of 7 when 10 less than or equal to x and less than or equal to 27. So it means that the value of EI, it will be taken 2 into 10 power of 7 when the length of this, where x it will be a length of the element. So from 0 to 10, if having the length in that range, so the value of EI should be taken as 2 into 10 power of 7. So when it starts from 10 to 28, whatever the range from 10 to 28, in that case you have to select as 10 power of 7 as EI value. So here you can see the question, the beam element which is given, where the beam element, it is left end is supported by a roller end and in the right end it is supported by a rigid end. And from 0 to 10 mm, okay, so it will be 0 at here where the node is roller node supports is acting, where the limit it will be starts from a 0 and the length it will be 10 meter to this where the cross section is changed. And here for this element the UDL is acting. Okay, so distributed load is acting with a load of 2400 Newton meter, right? Again in the stepped bar, again it is divided into two parts because the where the point load is acting, that is 10,000 Newton is acting at a here, okay, at this node. So from 10 to again it is added with a 12 meter, again from 12 it is added with 6. It means the total length of the beam element is 10 plus 12, it is 22 plus 6. So 28 meter is the total length of the element. So as it is mentioned 0 to 10, it means for the element 1, and 10 to 28. So it is for the element 2 and element 3. Means for the element 2 the length it will be 0 to 22 here, it means 10 to 22, again 22 to 28 will be the length for the element 3, right? Hope it is clear to you. Now this is the discretizing the body diagram into a line diagram, the finite element discretizing method they have made. So in a beam element at each node, as you know, there will be two deformation. One, it will be vertical deformation, another there will be rotation deformation. Okay, so at each node, like this will be your node 1, here it will be node 2, node 3, node 4. So there are 4 nodes and 3 elements. So this will be element 1, element 2 and this will be element 3. I think it is clear to you. Now this is the stiffness equation. Okay, stiffness equation for a beam element where K is equal to, it is EI by L cube. Okay, in the 4 into 4 matrix, this you have to remember. So 12x 6l minus 12 6l, 6l 4l square minus 6l 4l square minus 12 again minus 6l 12 minus 6l 6l 2l square minus 6l 4l square. So here the at the top end you can see there are some nodes. These are the nodes or displacement that is represent, like 1 to 4 it is represent. It means at each node, this is anyhow, this is for the element 1. Whatever the equation you have written, it is for the element 1. So that's what we have made as K suffix 1. So this is related to only the element 1. We are taking only this element now so far. Okay. So EI by L cube. So what is the value of EI? So when the length distance it from 0 to 10, then you have to take as 2 into 10 power of 7 for the element 1. Okay, so 2 into 10 power of 7, which is already taken, by length. What is the length of the element 1? It is 10 meter. So you have to take as 10 cube, that is L cube. Again, in the bracket, you just substitute the value of L. So there is a L, you can see in all the equation. So wherever the L is there, just substitute the L in this equation. Okay, make a multiplication of L. It may be in the form of multiplication, or sometimes L square is there, that you have to make carefully. Okay, if a small mistake can also make a big difference in the answers. Okay, then you have to, after substituting the L in the equation, you will get this form. So here again 1, 2, 3, 4 you can write. Again, this is for the stiffness matrix for the element 1. Okay, now you can make this as one solid equation, or you can go for making the substituting in the calculator, and you will get a one equation here, or directly you can keep as it is. Okay, then second thing, for the element 2 now, what is the stiffness matrix for the element 2? That is K2. Okay, for K2 it is, okay, so distance it will start from now, so here, okay, so 10 to 22 now. Okay, so for that, what is the range here? 10 to 22 means x will be at the middle of this. So in that case, you have to take as 10 power of 7. And what will be the length of the element 2? That is 12. Remember, 10 power of 7 into by 12. Length is 12. EI will be 10 power of 7 by 10, 12. 12 is the length for the element 2, power of 3. Again, same 12, you can make the multiplication. You can substitute in this matrix wherever there is an L. Then after that, you will get in this equation. Like 3, 4, 5, 6, 3, 4, 5, 6 are the displacement at element 2. Okay, so 1, 2, 3, 4. Now again element 2 is started from 3, 4, 5, 6. So 3, 4 is for node 2 and 1, 2 is for node 1, 5, 6 is for node 3. Then finally you will have the another element, that is third element, where again the EI value it will be same, that is 10 power of 7, and length will be changed. So that is 6 you have to take in the equation. So EI will be again 10 power of 7 by 6 cube. So now substitute the value of 6 in the matrix, then you will get this equation. So now what you have to write here, for this is for the node 3, that is 5, 6, these are the displacement at node 3, and 7, 8 is the displacement at node 4. So that is the fixed node where you have taken as 7 and 8. So after that, after calculating the stiffness matrix for each element, then you can go for making the global stiffness matrix. That is where K into U is equal to F. K is the global stiffness matrix. Q is the displacement vector. F is the force vector. Right. So now how to add this global stiffness matrix? First, how many displacement you have? Total 8 is there. Okay. So make a 8 into 8 matrix. So number of rows are 8 and number of columns are 8. So now this will be becomes a 8 into 8 matrix. So you have to look at the all the matrix now. This is matrix 1, 2, 3. So now 1, 1, there will be value of 12. The first row and the first column, what is the value? 12. So like that you just remember. So 1, this is the first row and this is first column. So whatever the value you will get, that is 12, you have to substitute here. Before that, okay, so before that, make sure that whatever the outside value, that should be taken as a common. So here whatever the value, that should be taken as common. So now we can see there is a lot of difference between equation 1, 2, 3. Now make this is as a one equation. Okay, so one equation, then you can take inside two in the matrix, and whatever you will get, that will be a solid matrix now, so that you can add directly in the matrix. Now in this equation they have taken as 1 into 10 power of 7 as a common, because here also you can take 1 into 10 power of 7, by 12 cube is there and here 6 cube is there. So only you can take 10 power of 7 as a common. Then they have taken 10 power of 7 as common, and whatever within the matrix, that you can do the same procedure. Like as I told you, 1 1, that will be 12. Now here it will be 12, you can obtain. Now 1 2. So similarly you can match, you can observe in the other matrix, because it is a continuous matrix. So for this type of case you won't get much confusion. So because 1 1, it will be easily get. Only in case of 3 4 and 3 4 you will have 2 times, and 5 6 5 6 again you will have 2 times. Okay, so 2 times you need to observe and you have to add the values. So like that we will get the global stiffness matrix. So if you are having any doubts, still you can go for watching separate video on the global stiffness matrix. So there you can clearly you can understand how to make the global stiffness matrix. A separate video is made on global stiffness matrix. Okay, then now I will continue. So this is K. Now finally we will get the K. Again this is the Q value, that is the displacement deformation at each node. So here Q1 Q2 is taken. Okay, so Q1 Q2 is nothing but it is the one Q is Q1, whatever the odd numbers are coming, so that is the vertical displacement, and E1s are coming, that is the rotation displacement. Or if you are still getting confusion, then you can go for V theta. In many textbook it will be referred as a V is the vertical and theta is the rotation. So like that also you can take if you are still confusing. So Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8 are taken. So all these odd numberings like 1, 3, 5, 7. So these are the vertical displacement, and the Q2, Q4 are the rotary, means rotation displacement. Again,
so now the force vector, where it will be this value, it will be taken from the calculation. So for this problem, okay, so it is a simply supported beam with a UDL. So here for this, the shear force, it will be WL by 2. Okay, remember it will be WL by 2 is the force, and bending moment it will be WL square by 12. So WL square by 12. So WL square by 12, it will be the equation. So I can write here. So force, it will be W L by 2. Okay, and sorry, and bending moment, it will be W L square by 12. Okay, so you just remember this one. Now after that, so here this value you will get. So when you will substitute the F1, so that is WL by 2. So what is the value of W? That is 2400, and L is 10 meter divided by 2. So you will get 12,000. So that is written as 12,000. And this should be 20,000. It is not a 2,000. One more zero is missing here. It should be 20,000. It means W 2400 into L square, that is 10 square is 100 divided by 12. So you will get 20,000. Okay, similarly for F2 at node 2 there will be F2. So F1 and F2 it will be same, because the UDL load is acting at node 1 and node 2. So it will be same. So F2 is acting in the same. So 2400 again. So again you will get a 12,000 as F1 and F2. Again WL square by 12 is also, you will get the same, because L is same. So here we have taken as minus 20,000. It means for the bending moment, due to the bending moment for the UDL, so when this UDL is acting on the beam, so here this the bending moment it will take in the clockwise direction, where at here at node 2 it will take the anti-clockwise direction. So that's what will take plus for the node 1 and minus bending moment for the node 2. So you have to take as minus 20,000. Again here the minus 10,000, that is for the point load, it is acting downwards, so minus 10,000 is taken, right? So after that you have to make the elimination method. It means the first row it will be remain same, because first okay, no, the first row q1 it will be 0 as per the boundary condition. Q1 vertical displacement it will be 0, where this first row and their first column it will get cancelled. Similarly Q2, Q3, Q4, Q5, so this value it will be known to us. Okay, Q5 and Q6 also. Only Q7 and Q8 it will be 0, because at the last it will be fixed end, so it will be taken as 0 0. So 0 0 you have to substitute, and their last two rows and two columns, these two columns you have to make elimination. So whatever the remaining you will get, so remaining this one you have removed, so 0 0.8, 0 0.12 and 0 0.400 it will be remaining. Okay, so that will be in the remaining box. So in the Q3 also same, this value, these three values will be there. Q4 this value will be there, Q5 will be there, and Q6 will be there. So like that there will be now 5, yes, there will be now 5 displacement. Okay, so 5 displacement we can find here. Okay, so now after this elimination, so this is again the same step for calculating the F, and here it is followed using the equation. So whatever you have substitute here, the F equation, so the steps for them it is written here. So these are the boundary condition, whatever I told you just now. So these are the boundary conditions. Now after elimination you will have this matrix. Okay, and these are the displacement and these are the forces. So here you can see there are 5 displacement, these are the 5 unknown displacement. So now there are 5 unknowns, you will get it. Okay, so it will be quite difficult to make separate equation. So by making the 0.8 Q1, so this first row and the column you have to make multiplication like 0.8 Q2 minus 0.12 Q3, 0.4 Q4, 0 0 you will get. So is equal to 20,000. Again second equation also, second row first column you have to make multiplication is equal to 12,000. Third equation, third column you have to get minus 20,000. Fourth minus 10. Fifth is equal to 0. So same in the form of you will get all these equation you will get. Okay, so you have to do manually, or if you want to know by using the scientific method, so here you can go for in the Google, you can search like 5 unknowns equation calculation. So simultaneous linear equation solver you will get. So this is in the website handymath.com, there you will get it. So here how they will have the one, there will be one table. So I think this table is visible to you, many of you can observe. So here in this table, so in the left side there are another 3 tables it is there, so that is not covering the recorder. So there you have to substitute all these unknowns, like whatever the numberings, like here how much it's showing, this will be now third, so third is completed, fourth 5, so fourth and 5. So what is there in the fourth and 5? Suppose in the first equation if you taken, so in the fourth and 5, this is first, second, third, fourth and 5, it will be 0 0. So you have to substitute as 0 and 0, then is equal to, you will get it. Again in the second equation, same second equation, here 0.006 is there, so minus 0.006, is the, so like this you have to enter minus 0.0006. So 0.14 is there in the last column, I think. So 0.41. So 0.41, 0.41, 0.041. Yeah. So like that you can enter, and if you enter finally, then there is a one calculate. So you will get the value of 1, 2. It means Q2, Q3, Q4, Q5, Q6 value you will obtain. Okay. So this is the easiest method where you can calculate. Then again you can go for manually. Okay. So these are the steps you need to carry out to calculate this displacement. Okay. Guys, thank you for watching this video. Please subscribe the channel if you are helpful for you, and also if you can share with your friends if anyone needed this type of problem. So thank you again.